Hello, my name is Loren Mora Pastrana, and I will present to you the work entitled Organic Thin Fields by We Process for Feasible Bulk-Heterojunction Organic Solar Cells. This work is a collaboration between startup AutoCoach, G Molecular Electronic Group of the University of São Paulo, the University of Latin America Integration, and the Federal University of ABC. The thin films were deposited by two different techniques, spin and belt coating. The layered structure of the manufactured organic solar cells is shown in this image. GP.PC solution was deposited via spin coating and received. EPA was added at volume ratio of 1 to 3 in blade coating deposition. The volume of solution used per sample 1 for 1 square inches was 300 for spin and 14 microliter for blade. To define the organic solar cell contact, we used photolithography mask and ETO, each on the anode, and shadow mask during aluminum thermal evaporation to define the cathode. The sequence of steps for the deposition of the thin films is represented in this diagram. The substrate cleaning process and the solution is the same for both deposition substrate. Substrate used in spin coating deposition need surface treatment with oxygen plasma to the one used in blade coating are not. The optical, morphological, and structural characterization of the thin films were made on the equipment shown. Films thickness decreased with spinning frequency. The opposite occurred with the increase in the speed of movement of the knife for films obtained by blade coating. The circles with dashed line show the appropriate thickness for fabrication as a function of the deposition rate according to the process. The fourth picture were obtained using the atomic force microscopy. A and B show decreased roughness of the films when PDOT species is diluted in EPA and deposited by blade coating. C and D show that in solution with higher concentration, the roughness increase. Reduced roughness is expected to prevent short circuit in different layers in the organic solar cell structure. PDOS species adsorbance is lower than the semiconductor layer, which is desirable for exciton formation in the active layer and consequently achieve high power convection efficiency. Even better, PDOT species films by blade coating fewer and even lower absorption in the visible range. It is worth saying thickness films were applied in order to have more noticeable peaks in this spectra. Despite the addition of EPA for blade coating deposition, the relative intensity and position of the peak remain unchanged. In summary, even after EPA addition and thermal treatment, it can be inferred from optical characterization that the chemical structure of PDOS was preserved during processing. P3HG PCVM dissolved in dichlorobenzene with a weight ratio 1:1 and a concentration of 26 milligrams per 4 milliliters were deposited by two techniques showing that the films, except for the intensity that decreased along with the thickness, the chemical structure is preserved. Diffractograms show a peak in 5.3 grade, typical of P conjugate P3HG 100 with lamella perpendicular to the substrate. In algorithm USB advanced with advanced data. This is a sign of lower crystallinity at higher deposition frequencies. On the other hand, blade coating is probably forming more crystallinity films. Some high crystallinity films are desirable to improve charge transport after excitation dissociation. Exciton dissociation. 26 milligrams for milliliters and 700 RPM, a bit suitable for organic solar cells application. Thin films investigation by different techniques featured ruggedness, thickness, and crystallinity suitable for organic solar cells application. PDOS species dispersion must be deposited at 2100 RPM. P3 HG PCVM must be dissolved in dichlorobenzene at 26 milligrams per milliliter and spoon at 700 RPM. PDOS species did not degrade upon drying. Blade coating provides thinner HGL films with reduced ruggedness. The thermal annealing of P3HG PCVM did not degrade the films and it significantly enhanced crystallinity at frequencies lower. Thank you for your attention.